Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. Now the next topic I want to talk about is U-Substitution. So I looked at the notes for U-Substitution and how they show it in the textbook. And I don't understand how that's even allowed to be released to the public. That explanation for U-Substitution was so horrible, so horrendous. I'm pretty sure you're actively becoming dumber just looking at it, how confusing it is. I don't even remember what it is, how they explained it, but I'm going to explain it my way. It's going to make sense, and that's all you care about anyway. At least that's what I care about. I don't care about the grade. I care about if things make sense, honestly. If you can try your best in this class, even if you fail, well, obviously you don't want to fail, but if you at least try your best in this class, that's all I care about. And if I can make that suffering a little bit less, well then I'm making the world just a little bit of a better place, and that's always my goal. Okay, enough of the sappy motivational stuff. Back to the problem. We have the integral of x squared minus 4 cubed times 3x dx. Again, this is going to be a U-substitution problem. U-substitution. Now, how do I know this is U-substitution? That's a great question. So U-substitution is going to show up whenever you have one of the three cases. A product rule, which is what we have here, a product rule. A chain rule, which is also what we have here. Or a quotient rule. If it looks like any one of these three rules in the integral, in this case we have two of the three, which is really bad, it means we're going to use a U-substitution in order to solve the integral. And the reason we do that is because we don't actually have a product rule or a chain rule or a quotient rule with integrals. We just don't. Sorry. But I've got good news and bad news. The U-substitution is more fun than all of those three rules. It's less memorization like you would for those three rules. The bad news is because it's more free form. It's kind of like jazz. There's a lot of choice on your end in terms of how you solve these problems. And for that reason, if you don't know what you're doing, it's really hard, if not impossible. But luckily, we're going to be going over a bunch of examples today, so I don't think that will be a problem. So let's start off by picking a u. I need to choose a value for u, and I guess it's a good point. You have no idea what u to pick. U could literally be anything here. So I'm just going to tell you what the right answer is at first, and then we'll talk about why. I'm just going to tell you, let u equal x squared minus 4, the thing in the parentheses right here, okay? U equals x squared minus 4. Then I need to take the derivative, not the integral, the derivative. And I'm not going to say u prime. I'm going to write du dx, and you do not have a choice here. You have to write du dx, not u prime. And you'll see why in a second. But the derivative of du dx is going to be, well, derivative of x squared minus 4, that's just 2x, right? So I have du dx, it's 2x. And actually what I want to do here is I want to solve for dx. So I'm going to multiply both sides by dx. On the left I just have du. On the right, I then have 2x dx, and then I just need to divide both sides by 2x, and we'll end up getting dx equals du divided by 2x. Dx equals du divided by 2x. Now, why is this important? Well, I'm going to plug in this value for dx right here into my integral, and I'm also going to plug in u equals x squared minus 4, into that spot right there. The 3x I'm not going to touch. I'm going to leave it as 3x. And here's what this integral is going to look like now. It's going to be the integral of, now instead of x squared minus 4 cubed, it's just u cubed. Much easier. 3x stays the same. And then dx, we just set it down here. It's du divided by 2x. Du divided by 2x. Now, how on earth did this help us? This looks more complicated. Well, I'm glad you asked. So the goal of a U-substitution, first of all, is to make the integral simpler. The second goal is to make sure we cancel out all of the x's so that we're only left with u's. Notice here I have a 3x in the numerator and a 2x in the denominator. The 3 and the 2 won't cancel, but the x's do, because this x is in the numerator, that x is in the denominator. And also with this 3 and this 2, I'm going to write out in front as coefficients a 3 in the numerator, a 2 in the denominator, times the integral of u cubed du. So sure, this might not be x cubed dx, but it's the exact same thing except we're dealing with u now. And so what I'm going to say is the integral of this, and by the way, this is an indefinite integral, right? Because there's no bounds. we're going to get plus c at the end. So it's 3 halves, because that's the coefficient, times the integral of u cubed is going to be u to the 3 plus 1, so 4, divided by 4, and then plus c. Now, this is not the final answer quite just yet, and that's because our final answer cannot have u in it, because we started with x's. So the last step, plug back in x squared minus 4 for u. I can also simplify the coefficients. So that's going to look like 3/8 times the quantity x squared minus 4 to the 4th power plus c. This is our final answer for the u-substitution. And again, good news, we can check our answer by taking the derivative, right? Now, for this problem, I mean, I'm not going to lie, this is not easy to take the derivative, but if you were to take the derivative, you would end up with your initial problem in the integral, which was x squared minus 4 cubed times 3x dx. Any questions on that one? We're about to do a bunch more u-substitution problems. Oh, one more thing. Why did I choose u equals x squared minus 4? Let's talk about that, because that's actually a good point. So I'm going to tell you there's a few different options I could have chosen, right? I could have chose x squared minus 4, which I did. I could have chose x squared minus 4, the whole thing cubed. I could have chose that. I could have just chose 3x. How do I know it was x squared minus 4? Here's what I'm going to tell you. I like to use the Goldilocks principle. It's a theory I made up, patent pending. And it pretty much says for a u-substitution problem, you don't choose the thing that's too short. You don't choose 3x. You don't choose the thing that's too long. You don't choose x squared minus 4, the whole thing cubed. You choose the thing that's just right, which is the thing in the parentheses here. And most of the time it is the thing in the parentheses. It's usually the thing in the middle. And, of course, you could be wrong. If you are wrong, well, first, it sucks because you have to redo the whole problem. But how do you know if you're wrong? We'll talk about that later, too. So next, let's just do another u-substitution problem. Just get in the swing of things. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks, everyone. Bye-bye.